Good afternoon, all the boys and girls of 12th class. Now we are going to see the solid state. The different points that we have to see in the solid states are, we will see one by one so that you can completely understand the solid state. Already you are knowing solid state, liquid state and gaseous states. These are the three states of matter. Already you have studied this in 9th class, 11th class, but in this class you have to study the solid state in details, especially crystalline solids, then packing in the solids, then packing efficiency and different types of magnetic and electric properties. So we will see one by one. Now let us see, in this chapter we have made three different parts of this chapter. So in the first part, we will going to see the characteristics of solids, classification of solids, classification of crystalline solids, crystal lattice and lattice points, unit cell, Bravis lattices, lattice points in unit cell. So see one by one. First, when you talk about the characteristics of the solids, it is seen that solids are definite shape, volume, rigidity, incompressibility and high density. It means that solid have definite shape and definite volume. This is the perfect definition of the solids. Moreover, solid cannot be compressed. Hence, it is called as incompressibility. It is rigid, it cannot move. Hence, the property is called as rigidity. And generally, it is having high density. When you take the example of metals, for the density, it is seen that a metal like, noble metal like gold having high density, that is 19.6 gram per centimeter cube. Therefore, from the gold, we can, 1 gram of the gold can make 2 kilometer of the wires. This is the specialty of the gold. So the solids, different constituent particles are there. It means these are the atoms of the solids. So they are closely packed with each other. Hence, they can occupy their fixed position. They cannot move from one another. You can see this solids packing here. Secondly, when we see the solids, there are two types of the specially solids. One is crystalline solids, which are having crystals, whereas second is a powdery form solid, that is called amorphous solids. Now, what are crystalline solids? Crystalline solids are generally orderly arranged. The particles of crystalline solids are orderly arranged. They have long range order along with sharp melting points. Moreover, crystalline solids are anisotropic in nature. It means that some of the physical properties like refractive index of the crystalline solids are different in different directions. Then these solids, crystalline solids, are considered as a true solids because they are having orderly arranged structures. They undergo a clean cleavage. When you cut it, it can form the perfect crystal. Hence, also they are called as true solids. Crystalline solids have definite heat of fusion. Definite heat of fusion means when you melt it, a sharp melting point is obtained. That is called definite heat of fusion. Diamond, graphite, metals like iron, cobalt, nickel, gold, then the compounds like NaCl, ZnS, KCl, etc., etc. All these are the crystalline solids. Now, amorphous solids. Amorphous solids are those in which their constituent particles have no regular arrangement and have short range order, whereas no sharp melting point, but they are showing their melting point in a range. For example, they can show like the temperature range 300 to 320, 400 to 450, like this. They are isotropic in nature. It means physical properties of the amorphous solids are same in all directions. Moreover, they are called as pseudo-solids. Because of the pseudo-solids property, they can form super cool liquid. For example, the glass is an amorphous solid. When we heat it, it can melt, it can fuse, and they can flow as a liquid. Hence, they are called as super cool liquids. Now, amorphous solids, they are irregular cleavage. They can form irregular cleavage. You can observe here the powdered form of the amorphous solids. So, amorphous solids on heating become crystalline at a particular temperature. Means amorphous solid at a particular temperature can form crystals. Hence, they are become as a on heating crystalline solids like glass. From ancient time, they are appear as a milky. Why? Amorphous solids have fluidity property. Why? All these are the points that will come across in the whole chapter. Now see, types of crystalline solids. There are four types of the crystalline solids: molecular solids, ionic solids, then metallic solids, and covalent or network solids. These are the four types of the solids. That is molecular solids, ionic solids, then metallic solids, covalent or network type of the solids. These are the four types of crystalline solids. So what are molecular solids? Molecular solids in which constituent particles are polar. Polar means when in the particular compound having 1.9, more than 1.9 electronegativity difference, such solids are called as polar. When less than 1.7, then it is a non-polar. So water, HCl, these are the polar molecules. So the constituent particles in the molecular solids are polar or non-polar or hydrogen bonded. These three: polar, non-polar or hydrogen bonded. Secondly, force of attraction is dispersion force or dipole-dipole interaction or hydrogen bonding. These are the three different types of force of attractions which are present in the molecular solids. First, we have seen molecular solids are polar, non-polar or hydrogen bonded. Second, we have seen the force of attraction is dispersion force, or it is also called as London force. Second, dipole-dipole interaction. Third, hydrogen bonding. These are the three types of the forces present in molecular solids. They are having low melting and boiling points. They act as insulators. These are the properties of the molecular solids. Second, ionic solids, just like NaCl crystal, KCl crystal, CSCl crystal, ZnCl2 crystal. Okay, so these ionic solids, constituent particles are ions. When NaCl undergo fusion, there is formation of Na positive and Cl negative. Na can liberate or release one electron on oxidation to form Na positive, and Cl gain electron can form Cl negative. So the constituent particles are ions. Force of attraction is ionic bond only. High melting and boiling point. They are electrical insulator in the solid state, but in the molten state or in aqueous solution, they behave as a conductor. Remember this one. So when you going to differentiate between the molecular solids and ionic solids, you can clear-cut differentiation you have with you. That is, constituent particles are ions. Then force of attraction is ionic bond. High melting and boiling point. They act as a insulator, electrical insulator in the solid state, but in the molten state or aqueous solution, they act as a conductor, electrical conductor. Then third type is metallic solids. In case of the metallic solid, constituent particles are positively charged metal ions and free electrons. It means that you can easily see that iron, when iron get heated, then iron can form 2 electrons, they can separate, or sometimes it can separate 3 electrons. The atomic number of iron is 26. So the particles or constituent particles of the iron, these are positively charged as well as free electrons. Hence, these irons, copper, silver, magnesium, gold, these are called as metallic solids. Secondly, force of attraction is metallic bond itself. Thirdly, high thermal and electrical conductivity. Thermal conductivity means when you put heat at one tip of the rod, at another tip you can experience the heat. That is thermal conductivity. Electricity, you are knowing, from one place to another place electricity can be flow. So high thermal and electrical conductivity, they are malleable and ductile. Do you know malleable? Malleable means with the help of hammer we can form the thin sheet, malleability. Ductility, we can form the wires. We have taken earlier the example of gold. 1 gram of gold can form 2 kilometers of wire. They are having high melting and boiling point. So these are the properties of the metallic solids. So you can have difference between that is metallic solids and network solid also. You can have the difference between ionic solids and molecular solids. Okay. So in the covalent or network solid, this is the fourth type of the crystalline solids. Constituent particles are neutral atoms. Here neutral atoms. Force of attraction is covalent bond. As it is a covalent solid, hence force of attraction is covalent bond. They are neutral atoms. They are having high melting points. They act as an insulator. You can see graphite, exception is graphite. They act as a conductor. But diamond, quartz, silicon carbide, SiC, then aluminum nitride, ALN, these are the insulators. Only graphite is conductor. Okay, so in this way, we have seen all these four types: molecular solids, then ionic solids, then metallic solids, then covalent or network solids. In this way, we have seen all the four types of crystalline solids. Dear students, now we will switch over toward the next point, that is crystal lattice and lattice points. Now you are observing this NaCl crystal. The speciality of the NaCl crystal is that one Na atom or Na positive surrounded by the 8 Cl negative ions, whereas one Cl negative is surrounded by the 8 Na positive ions. In this way, one cube of NaCl is formed. When such cubes like atoms, ions or molecules repeated in 3D structure, when it is repeated in 3D structure or 3D space, three-dimensional space, there is formation of a crystal lattice. We call it as a space lattice also because this three-dimensional arrangement takes place in a space. So a regular arrangement of the constituent particles like atoms, ions or molecules by a crystal in three-dimensional space, that is called crystal lattice or space lattice. Each point or atom or ion or molecule in the crystal lattice is called lattice point, or you may call it as a lattice site. Clear now? Lattice point or lattice site, each point of the crystal. Now we will see unit cell. What is unit cell? Here we have taken one cube. Okay, here three edges are there, ABC, and in these three ABC edges, three angles are there. The angle between C and B edge is alpha, angle between C and A edge is beta, angle between A and B is gamma. So these unit cell are having 6 parameters, that is 3 edges and 3 angles. Okay, so what is unit cell? Unit cell is the smallest portion of the crystal lattice, which are having a repeated different direction pattern, that is called unit cell. Specially defined, unit cell is the smallest portion of the crystal lattice, which when repeated in a different directions, we generate the entire lattice. When this unit cell repeated in number of times, like horizontally and vertically, there is formed the entire lattice. And in this unit cell, there are 6 parameters, 3 edges and 3 angles. Now, how you can calculate? How you can classify the unit cells? Unit cell can be classified mainly in the 2 types. One, primitive or simple unit cell, and second, centered unit cell. Primitive or simple unit cell and centered unit cell. What is primitive unit cell? Primitive unit cell are that when constituent particles are present only at the corners of the unit cell. You can look here. At the upper side, 4 corners are there. At the lower side, again 4 corners are there. There are 8 constituent particles present at the upper and lower side. Hence, the constituent particles present only at the corners of the unit cell. Therefore, this type of unit cell is called as simple unit cell or primitive unit cell. Second type is centered unit cell. In case of the centered unit cell, the constituent particles are present at and other centered portions. Where they are present? They are present at the corner as well as at the other center. What are the other centers of the unit cell? Apart from the corners, other 2 centers are there. Other one center is face. and other center is body. These are the two centers apart from the corners. Followed? There are 8 corners. There are 6 faces and there is one body also. Main body. There is one main body. There are 6 faces and there are 8 corners. When all the 8 points are present at the 8 corners, that is called primitive or simple cubic cell or unit cell. But in case of centered unit cell, there are 3 types. One, body centered unit cell. In case of the body centered unit cell, the constituent particles are already present at the 8 corners. Moreover, from the 8 corners, one of the body or one of the point is present at the body. One of the point present at the body of the or center of the body. When one of the particle present at the center of the body and all the 8 points are present at the 8 corners, such arrangement is called as body centered unit cell, BCC. How many number of points are present in BCC? Only 2. 2 points are present. How 2 points are present? When 8 corners are there, then at the 8 corners, when you go and look the point, then only 1/8 of the portion of the point can look. So 8 into 1 by 8 equal to 1. And one of the point present at the center of the body. So 1 plus 1, 2. So there are 2 points present in the BCC. Secondly, face centered unit cell. Already I told you that there are 6 faces. So 8 corners, 8 points are there. 8 into 1 by 8, that is equal to 1. There are the points which are present at the 6 faces. So top face, back face, left face, then that is the right face, upper and lower. In this way, 6 faces are there. 6 points are present at the 6 faces, but only half of the point is looking to you. Hence, 1 plus 6 into 1 by 2. 1 plus 6 into 1 by 2. That is equal to 1 plus 3. 1 plus 3 is equal to 4. So, the constituent particles which is present at the face-centered unit cell are 4 only. What is end-centered? In end-centered, these are the points present at the alternate faces. Therefore, the value of points which are present, which are looking full on the alternate face. Therefore, the value of the points again 4 in the end-centered. In this way, there are 3 types: body-centered, face-centered, end-centered are the types of centered unit cell. After centered unit cell, you can have the discussion on Brevis lattices. Already on the page number 3 and 4, these Brevis lattices and its figures are there in the solid state textbook chapter. Now, what is Brevis lattices? Brevis was a scientist who has discovered the different lattices. These different lattices are 7 in number. These 3-dimensional lattices are 7 in number, which are the further extension of the primitive and centered unit cell, that are cubic, tetragonal, rhombic, monoclinic, triclinic, trigonal, and hexagonal. Okay. So on the basis of 6 parameters, just now we have discussed, there are 6 parameters to the unit cell. So on the basis of 6 parameters of the unit cell, 3 edges and 3 angles, total number of unit cells of the primitive and centered unit cell in 3-dimensional are 14 number. These 14 number of the 3-dimensional unit cells are called as the Brevis lattices. So in these Brevis lattices, you can see cubic lattice is there. Example, NaCl, KCl, diamond and copper. Tetragonal is there. In SnO2, CaSO4. Rhombic is there. Then KNO3, BaSO4. Monoclinic is there. Monoclinic sulfur, sodium sulfate. Triclinic is there. That is potassium dichromate, copper sulfate. Trigonal is there. Limestone and mercurous sulfide. Hexagonal is there. Graphite, zinc oxide and ice. All these are the different Brevis lattices. Their age lengths and bond angles you can very well understand when you study the textbook and its point. Now, these are the Brevis lattices: primitive, end-centered, body-centered, face-centered, then primitive and end-centered, that is having different age lengths. Then here Brevis lattices, primitive, body-centered, face-centered. In this way, extension is there. Now, the last 3, that is here hexagonal lattice, in which one side different in length than the other 2, whereas the angle is 60. Here rhombohedral, all the sides are equal length, angles are less than 90. Third triclinic, the unequal sides ABC, whereas the angles are never 90, means more or less than 90. So in this way there are 14 Brevis lattices are there. Now just now we have discussed earlier number of atoms in unit cell. So this is the calculation of calculating how many number of atoms present in a simple cubic, body centered and face centered. So see 8 into 1 by 8 in the primitive or simple cubic, 1 atom. In body centered, 8 into 1 by 8 plus 1, that is equal to 2 atoms. In third, that is face centered, that is 8 into 1 by 8 plus 6 into half, that is 4 atoms. So in this way, in case of the that is number of atoms in unit cell, for simple cubic 1 atom, body centered 2 atoms, face centered 4 atoms. So what we have studied till now? We have studied the characteristics of solids. We have studied the classification of solids, crystalline, amorphous. We have studied the classification of crystalline solids into 4: molecular, ionic, metallic, covalent. Then crystal lattice and lattice points we have seen. Unit cell we have seen, primitive and centered, BCC, FCC, ECC. Brevis lattices we have seen, that is 7 primitive Brevis cell and 7 centered units, Brevis lattices. So there are 14 types, 7 primitive and 7 centered. Okay, so in this way, these are the points that we have studied in this part 1 of the solid state. Now these are the questions. Question you can solve. Write a feature that will distinguish a metallic solid from ionic solid. Second, write a distinguished feature of the covalent solid. Third, why graphite is good conductor of electricity, although it is a network or covalent solid. Last, what type of interactions hold the molecules together in a polar molecular solid? So these are the 4 different questions can covered in this topic. Thank you one and all.